There's a small section in the book that talks about Grignard reagents. We're going to go ahead and do a synthesis problem here that might seem a little advanced, but it's actually not too complicated, and I think it'll kind of help up, almost wrap up synthesis, and almost wrap up this chapter for the assessment on Monday. We are given, this is I think the try it section in the book, like the one after they do the example with. We are given ethanol and aldehyde, and we are going to make this tertiary alcohol out of it. Okay? We have a carbonyl-carbon here to attack. I need to add carbons on there. I should be thinking Grignard reagent. We can see we need to add 2 ethyl groups with our Grignard, meaning I'll need to attack it twice. So let's go ahead and get started here. The only thing that's different now is that we should make our own Grignard reagent, and it shows that in the book in the reaction above this. I think it's 20.6, somewhere around there. It shows it pretty well, and then it gives an example problem. This is the example problem where we're going to do it. So the first thing I need to do is make my Grignard reagent. Where before we were either given it or we could just assume we had it. We know how to make one now. Basically, we need to get a halide, and then we just use magnesium, and that'll insert itself in between our carbon and our halide. So I'm given an aldehyde here. How can I go from an aldehyde to an alkyl halide? To go in between them, so my goal is to get a Grignard reagent. I'm adding 2 carbons at a time here. So my goal to get my Grignard should look something like this. That way I'm adding 2 carbons to these 2 spots here. Notice those are the 2 carbons I start with. I need a Grignard that's going to attack that spot twice, 2 carbons each. So I need to get from these 2 carbons with my aldehyde all the way to my Grignard. How I'm going to do that is first, I need to go from my aldehyde to an alcohol, and then from my alcohol I can get bromide, and then I can make my Grignard like so. So first I need to reduce my aldehyde down to a primary alcohol. A way I can do that is using NaBH4, okay? I should be able to use lithium aluminum hydride as well. Some type of H-, you could really just write H- here. Synthesis, we don't have to get very exact with things. H-, it's going to attack there, and then we would need something to protonate that O-. So how about NH4Cl? And I would number these as well, 1, 2, okay? That's gonna give us our primary alcohol. To make our Grignard, we need some type of alkyl halide. So to go from an alcohol to a bromide, PBr3. And then to make my Grignard for my alkyl halide, I just need to have magnesium, solid magnesium, and some sort of ether solvent. And I've gone all the way from my aldehyde, and I've made my Grignard reagent. Now we can actually use that in our synthesis. I'll just keep going, probably just up or left. And just go that way. All right, so my Grignard that I made can react with my starting material. Our Grignard has to have a place to attack, so it needs some sort of carbonyl, usually some type of carbonyl. So I can abbreviate my Grignard to just R minus. And it will attack our carbonyl, move those bonds up onto oxygen, and then I would protonate it. And I'm going to do that in a separate step. So attacks, I get O minus, and I add 2 carbons on. 1, 2. Let's protonate that. H plus. And then we'll get our secondary alcohol. Okay, I look at my goal. I'm almost done. I just need to add 2 more carbons on carbon number 2 there. So I need my Grignard to attack here. I need something to attack it with, or something for it to attack. How do I turn a secondary alcohol into a ketone, perhaps? I need an oxidizing agent to do that. So I could use either of these because both of them will turn secondaries into ketones. So I'm going to go ahead and just use PCC. Make a ketone. And now I can use that same Grignard reagent and add 2 carbons here and do the same steps right here. Instead I would be attacking my secondary here. So I just Grignard reagent, GBR, it's going to attack there. I can also protonate. I'll do it separate. I would do it separate steps. Minus, and then protonate. Get my alcohol there. So yes, it is a lot of steps, but I don't really think you'd have to do the whole thing, perhaps, maybe, but it really isn't that bad, I don't think. And that it adds a lot of what we've been doing. The only new thing is going from an aldehyde. This was chapter 18. PBr3, it's going to happen a lot in synthesis. PBr3 happened a lot in synthesis. This was our basically a Grignard step, and then from there we just used our Grignard reagent, attacked. We reformed it using PCC. Now we can actually oxidize something and do multiple steps. So we oxidized it again. That way we had something to attack, and again we had that Grignard reagent that we made in our first step. So combining reduction, making Grignard reactions, and oxidizing, really good synthesis there. The rest with MGBR and making that is not bad at all. Unlikely something full like this might happen on an assessment, but maybe just this shows up, or maybe just the second half shows up, something like that. You can same thing. You can design your own. Maybe make a Grignard, come up with some sort of a carbonyl, and you can make your own synthesis problem just like that.